Thank you for inviting Hughes Energy to present at the 2021 International Biomass Conference. My name is Dane McSpedon, CEO of Hughes Energy. I have been involved in the technology and infrastructure space most of my career with major companies like IBM, Oracle, and Honeywell. I want to share with you today the story and evolution of our waste to value technology. I have been with Hughes Energy for 6 years, the past 3 years as CEO. Hughes Energy is a US-based commercial organization of the Wilson Biochemical Company based in York, England. The Wilson Biochemical team are the inventors, engineers, and owners of our technology. We are the sister company that commercializes it. The Wilson system is a patent and know-how protected technology which has been deployed in the UK for 20 years. Our system is a high-speed composting system which uses steam and pressure, important to point out we do not burn or melt anything, to transform 20 tons of organic waste per hour into a biofuel which we sell. And the recyclables are cleaned, sanitized, and also sold for profit. The waste we compost consists of all organics in the various waste streams: food, scraps, paper, cardboard, grasses, and other organic agricultural byproducts. The most available and lucrative waste stream we process is municipal solid waste, which is household garbage. 20 tons per hour of municipal solid waste is loaded into the Wilson steam autoclaves. 60 feet long, 10 feet high, carbon steel vessels, which are closed after filled, pressurized to 70 psi, injected with steam, and rotated at 3 to 5 RPMs, like a giant washing machine. After an hour, the composted material is removed and sorted to send the non-organic material, which is the glass, the plastic, and the metals, to recyclers, and we are left with the biogenic sanitized Wilson fiber, which is then dried for further downstream uses as a solid and a liquid biofuel. But I always feel it is much more entertaining to show you a short video, which will give you a nice overview of the process in 90 seconds.
Disposing of garbage is complicated, time-consuming, and requires multiple stops. The distance from a transfer station to landfill is often long, and many landfills are filling up fast. And when the garbage gets to the landfill, the work is complex and costly. With a high financial burden and increasingly limited capacity, waste professionals need to secure their business for the long term. Hughes Energy has the solution. Hughes Energy installs a hyper-speed composting system which will transform 20 tons of garbage per hour into a saleable fiber, a renewable source of energy. The proprietary system uses steam technology to compost in 1 hour all the food, paper, and cardboard into a fiber, which is then sold for profit. Even the recyclables are fully sanitized and ready for sale. With Hughes technology, waste professionals turn a cost into profits. And by diverting all organic waste from landfill, they increase the amount of waste they can accept. Fully modular, scalable, profitable. Hughes Energy helps waste professionals turn costs to profit.
As you can see, the technology and the process is super simple. Every element of the system, steam boilers, pipes, the autoclaves, and conveyors have all been commercially deployed for over 150 years. A few things that are very important. First, our system operates at low temperature, 160 degrees C, so none of our material is melted or burned. Second, the Wilson fiber is not a refuse-derived fuel, which often includes shredded plastics. In fact, the fiber we produce has a legal standing in Europe and the UK called end of waste, which as a matter of law means it was never waste in the first place. Third, our waste to fiber plants have very few emissions to water, land, or air because we're composting the waste using recycled steam. In fact, the only emissions from our plants are that which comes from a natural gas boiler, which we use to raise steam. Our product, the Wilson fiber, is sold into the solid and liquid fuel markets on par with wood pellets, peat, coal, and crop-based ethanol. As I'll discuss now, there are two main avenues to market for the Wilson fiber we produce. There's a solid biofuel route and a liquid biofuel route. The solid fuel products, which are made from our fiber, are direct comparators to white and wood black pellets. Our Wilson pellet, which is akin to a white wood pellet, is about 6,900 to 7,200 BTUs per pound at about a 12% moisture level. Our torrefied Wilson pellet, which is akin to a black wood pellet, for which we have a patent pending, is 8,500 to 9,000 BTUs per pound at about a 3% moisture level. The pellets themselves can be made in any shape and size required by the customer. Our recommendation is that the Wilson solid fuels be used in a blended manner with traditional wood pellets for industrial scale biomass power applications. Each of our plants only produces 70,000 tons of Wilson pellets per year, which is much less than industrial power generators need. Wilson pellets should be blended with traditional wood pellets. As a green, renewable fuel, which is independent of weather, infestation, and sudden raw material price increases, Wilson pellets provide a risk hedge for customers. When we talk about the liquid fuel route to market, Wilson Biochemical and our partners have proven that we produce consistent, repeatable biochemicals and biofuels on a batch basis. Over the past 6 years, the Wilson team has won several high visibility, very competitive projects from the EU, the UK, and India, from government and private industry for the production of biochemicals from biomass. Some of our Wilson team's results have been published in European technical and scientific journals as breakthroughs in turning organic municipal solid waste to biochemicals. We've achieved the pre-production technology readiness level, which is known as TRL6, for biobutanol and bioethanol production. We are in advanced negotiations with a major European chemical company to build an integrated plant at industrial scale. Of course, all this sounds wonderful. It is wonderful, but let us take a look at why this is important. Climate change is obviously an enormous problem, full stop. Everyone knows that. While CO2 emissions garner the majority of the attention around greenhouse gas emissions, methane, which is 20 times worse as a greenhouse gas than CO2, has become a major source of concern, even among the general public, as well as scientists and policymakers. 16% of global methane comes from rotting organics in landfills. We eliminate this source of new methane because we extract the organic material from the waste stream. When we add the use of our fiber in a biofuel application, we are also addressing the largest emitter of methane in the world, the production and use of biofuels. The UN Intergovernmental Panel on Climate Change, or IPCC, is tracking against the global target set at the Paris Climate Accords, which aim to keep global temperature rise to 1.5 degrees Celsius. The IPCC has stated that in order to hit this target, a deep reduction in methane is critical. Current policies today in force are projected to cause, in fact, a 3 degrees Celsius global temperature increase, double the Paris target. This is in large part due to the inability of the world to produce biofuel for transport at a sustainable rate and cost. There are many reasons for this gap in the production of biofuel, but as with most changes, the reasons are primarily driven by economics. Food-based crops, usually corn in the United States, are the feedstock for most bioethanol production. And like wood for wood pellets, the cost of these food feedstocks are meaningful, especially when trying to break in against the fossil fuel industry, which has enormous economies of scale. Even with subsidies, it is very hard to make money by creating biofuel, as this graph indicates, and that projection is expected to go on to 2029. Unsurprisingly, the result is that the world is not producing enough biofuel to meet the targets we ourselves have established. As this graph shows from the International Energy Agency, the gap between what is needed and what is being produced is in fact becoming wider. The good news is the Wilson Biochemical team has a solution to produce biofuels and make money. Operators of our technology have a very favorable and enviable business model. There are not many industries where a factory is paid to take its raw material and is paid for the product which is manufactured. I think that's a very important element to what we do. We're paid for the incoming raw material and we're paid for the product manufactured. And that's true for the solid biofuels as well as the liquid biofuels. As it relates to biofuels, these economic drivers mean that we can produce biofuels at a cost which allows companies to make good money. There is a significant reduction in the production cost of biochemicals using Wilson fiber as a feedstock. How does the Wilson Biochemical team do it? Much like our hyperspeed composting system, which turns organic waste into fiber, the technologies and processes we use for biofuel and biochemical creation are proven and repeatable. We use a modified hydrolysis, distillation, and fermentation process to convert our fiber into biochemicals. These are the same exact processes which create beer and whiskey. So I think we can agree they're quite proven. A key technical point is that the steam autoclave process in the front end breaks much of the lignocellulose bonds in the organic material, making hydrolysis less caustic and cheaper. This has historically been a major problem in converting many organic materials into biofuels or biochemicals. Today, Hughes and Wilson Biochemical are working in partnership with a major European chemical company on a proprietary process to optimize the production of sugars and chemicals in the most cost-effective and repeatable way. These sugars are then converted into biochemicals or biofuel in a proven and very straightforward way. The results over the past 6 years have demonstrated a significant reduction in cost to produce biofuels from Wilson fiber versus traditional agriculture-based methods. Watch this space over the next 6 months for some major announcements. You will not be surprised, given everything I've told you today, that each Wilson plant offsets 200,000 tons of carbon dioxide equivalent per year. This is the same amount as 15,000 Americans produce every year. In the US alone, the Wilson technology has the potential to offset over 15 million Americans' CO2 footprint per year. Globally, the opportunity for CO2 offset reaches a higher order of magnitude. For the near future, using the Wilson technology as a means of producing biofuel from organic waste streams is a very practical, proven solution for the problems of waste management today. We can produce significant volumes of biofuel, which makes money without any subsidization. Each plant will produce approximately 3.4 million gallons of bioethanol every year. This is an important step in the creation of a more circular and sustainable energy economy. In closing, I wanted to show you, and please take a look at the plans for our waste to fiber plant under development today in New York State. We're super excited about it and look forward to plenty of visitors to the plant when it's operational. Thank you for allowing me to present today. My contact details are included in the deck, and we welcome hearing from you.